Hi there, my name is Dimitris Haralabidis. I'm a mathematics teacher, and in this video, we'll talk about Venn diagrams. To begin with, let me explain what a Venn diagram really is, and I'm pretty sure that all of you should have met at least once in your life such a diagram. Well, in probability theory, Venn diagrams are commonly used to represent the relationships between events and their probabilities. So that's their main reason of existence. That's the main concept behind a Venn diagram. A Venn diagram looks like what I'm drawing. At first, we have a big rectangle which notifies the universal set, and inside that rectangle, we have circles. These circles denote events, different events. These circles can be placed in any possible way inside the rectangle. And by that, I mean that they can be like this. These are called mutually exclusive. They can also intersect. They could be, for example, like that. Here we have A, and here we have B. These two circles intersect, have common parts. Or they could also be one inside the other. Assuming that this is A, we could have this being B. A Venn diagram may also include labels or numbers to indicate the size or probability of each set, of each event, of each intersection, and so on, as well as shading or coloring to differentiate different regions. So, for example, we could have this Venn diagram. This could have the label of math. This could have the label of PE. And inside that, we could have, let's say, we could have that 16 and that 8. And this would denote, for instance, that in the event of math, there are 16 persons. In the event of PE, there are 8 persons. Or we could easily have it split like this, for example, 9, 7, and 1, which would also indicate that there are just 9 persons who are just doing math, 7 who are doing both math and PE, 1 who's just doing just math, and 6 who don't do any of these two subjects, and so on. So, bottom line, overall, just remember that a Venn diagram is, simply put, a way to visualize relationships between events of a probability experiment. It consists of a main rectangle, which denotes the universal set of that probability experiment, and inside that rectangle, we place circles which notify the corresponding events we are working with. These events can be placed in any possible way. They can intersect, they cannot intersect, one can be inside the other, and so on. And sometimes, mostly basically, we label the circles so that we know what we're talking about, and we also escort them either by their frequencies or by their probabilities. That would be all. Hope it helped. However, if you still have any questions on what we just saw, you are always more than welcome to leave your comment below the video. As always, thank you for your time.